Okay, so we're going to continue with 2D vectors in the plane. So we're going to take everything we talked about yesterday and just keep building on it. Part of that is going to be defining what a unit vector is. Okay, we're going to look at writing vectors instead of in component form. We're going to write them as linear combinations of I and j. We're going to define I and j. And we're going to be able to state magnitude and direction. We've talked about magnitude already. We have not talked about direction yet. And then with all that, we're going to be able to find a unit vector in the same direction as a given vector and solve application problems. So, magnitude and direction. Magnitude we've already talked about in the first part of this. So the magnitude of vector v is the square root of 2 squared plus 5 squared. So it is the square root of 29. So that's the magnitude of the vector. Now what is the direction? Over here we have vector v. Placement doesn't really matter. I just chose to start it at the origin. We go right 2, up 5. So the direction is kind of like its angle if it were on the unit circle. The direction is always an angle in standard form, which means we're looking at starting right here and rotating in a counterclockwise rotation. So what is this angle? The way we can figure that out is thinking about this really just like a right triangle. Right, we have a right triangle right here. We know this length is 2, this length is 5. So then what is the direction vector? It's going to be, if we look at that, we would be able to say like tangent theta is 5 over 2. So then theta is the inverse tangent of 5 over 2. So in this case, our direction angle is approximately 68.2 degrees. So magnitude and direction. That is how we can find those. Again, magnitude's a review. Direction is just going to be inverse tangent of the y over the x. So moving on from magnitude and direction, what is a unit vector? So what is the unit circle? It's the circle of radius 1, centered at the origin. In math, the word unit usually has something to do with a length, like we did in the unit circle, of 1. A unit vector is a vector with a magnitude of 1. So that's all unit vector means. The direction could be anything, but the magnitude is definitely 1. Okay, so direction doesn't matter. Unit vector is only referencing the magnitude, which is going to be 1. So what are the standard unit vectors? I and j. Note that this is an I with a little hat, okay? It's not like I, the imaginary unit, it's I with a little hat, j with a little hat. We call these the standard unit vectors just because they're unit vectors in the x direction, horizontally 1, and unit vector in the y direction, vertically 1. So this vector right here written in component form, right, we'd have vector v is 2, 5. If we wrote that as a linear combination of I and j, we would say 2i plus 5j, right? This means move right 2, move up 5. This also means, right, I is moving right once. We want to move right once, twice, for a total of right 2. And then we want to move up 5. So component form looks like this. Linear combination of I and j looks like this, right? Just two different ways of saying the same thing is all that is. So then how can we find a unit vector that's in the same direction as the vector 2, 5? So we have our vector 2, 5 right there. We need to know the magnitude of that vector first. Okay, the magnitude of v, we said earlier, is the square root of 29. So then the unit vector, I'll call u, that's in the same direction as v, is going to be v over the magnitude of v. So you're going to take the vector that you're given and divide by the magnitude. So in this case, we can think of it as 1 over root 29 times the vector 2, 5. So that's going to give me the vector 2 over root 29, 5 over root 29. Okay, that is the unit vector in the same direction. So it's going to be probably somewhere like right here. Okay, so it's in that same exact direction from the origin. It's just instead of moving root 29 units, we're only moving 1 unit in that direction. Okay, and the key there is remembering the formula that we've got right. You just take the vector you're given and divide each component by the magnitude of that vector. So then what about thinking about these things the other way? We are given the magnitude and we're given the direction. We want to write out the vector as a linear combination of I and j. So what we have here is a vector looking something like this, okay, where this is 30 degrees. We can think about this as a right triangle. Here, we know this is 8. And so we have some x and some y that we're trying to figure out. We could use the idea that sine 30 is y over 8. So the y part is going to be 8 sine 30. Likewise, we could say cosine 30 is x over 8. So we're going to be able to say x is 8 cosine 30. So in component form, if we plug those in to get decimal approximations, 8 cosine 30 is about 6.9. 8 sine 30 is exactly 4. So that's component form. We're asked for a linear combination of I and j. So we're going to say 6.9i plus 4j. That is our vector v. So these are the formulas you want to remember. Is if you're given the magnitude and the direction, 8 cosine 30 gives you the x part, 8 sine 30 gives you the y part. And that's how you can make the jump to this. And then here I'm asking for linear combination of I and j, so that would look like this. If I was asking for the component form, it would look like this. If I wasn't specific, you could give me either of these two forms. So just as a wrap up, at this point you need to be able to tell me what a unit vector is. You need to be able to know what I'm asking for if I ask you to write a vector as a linear combination of I and j. You need to be able to state the magnitude and direction of a given vector, and then go the other way with it. If I give you magnitude and direction, you need to be able to give me the components, or the linear combination of the vector. And then you need to be able to find a unit vector in the same direction. Okay? In class, we will talk about solving application problems. So hopefully now you're going to be okay on most of this, which we will have time to work on these ideas to fine-tune those. And then we'll have some application problems we're going to look at as well.